So here guys, in this video we are going to solve what orthogonal trajectories, that application of differential equation concept. So here it is given that find the orthogonal trajectories of the family of asteroids. It is given over here. The family of asteroids, you might have heard that it is a kind of a graph in which you might have seen it's a asteroid name came from, it looks like a star kind of thing, right? You might have seen like this. Okay. So that's why the name came. Now we are not going detail in that. Okay, so that's why asteroid, a family of curves, in that it comes. So here, this particular equation, we have to focus on to this to find out the orthogonal trajectory. So let us start with the first step. Now the first and the basic step is to differentiate with respect to x, this term. And before that, let me just write over here, because steps will be different for the family, Cartesian family and polar family. Cartesian family basically have function of x and y, okay, two variables, and equal to c. C in the sense function of x and y on LHS, and c is a constant term on RHS. Okay, so here it is exactly given like that, constant term on RHS. Left side we are having function of. In polar family, what happens? Function of r and theta will be there. RHS side remains same, but LHS side function of r and theta. So we are focusing on Cartesian family since it is given Cartesian family. The first step becomes what? Differentiate with respect to x and eliminate c. So differentiate with respect to x and eliminate c. So we are going to differentiate this equation, right? So what is differentiation of x power n? You might have studied. It is n into x power n minus 1. Differentiation, okay? So same thing has to be applied here. So x power 2 by 3 differentiation is 2 by 3 into x power 2 by 3 minus 1 is minus 1 by 3. Okay, plus. Now y is there, but we have to differentiate with respect to x. So y power 2 by 3, again same thing, 2 by 3 into y power minus 1 by 3. But here again differentiation of y, which is dy by dx, equal to what? Differentiation of a power 2 by 3, which is a constant, equal to 0. That's why I written here eliminate c. So we have eliminated the c part, which is on the RHS side. So RHS side we are having only the c part. So we have eliminated the c part. We have got 0. Okay. So little bit simplification we will be doing here. So 2 by 3 you can take it outside. Now if we shift this 2 by 3 onto the right side, it will become 0 by 2 by 3. It will get cancelled, 0 itself. So final solution we can say is that final equation x power minus 1 by 3 plus y power minus 1 by 3 into dy by dx equal to 0. This we can say that in first step we will be getting the differential equation of the given family. Second step is basically to replace dy by dx by minus dx by dy. Okay, so what happens in the first step equation, that is equal to what? X power minus 1 by 3 as it is, plus y power minus 1 by 3. Now dy by dx will be replaced with what? Minus dx by dy equal to 0. Okay. Now I can take this particular LCM, I can take dy will be in the denominator. So I can just multiply here dy and dy, right? So what happens? X power minus 1 by 3 into dy plus y power minus 1 by 3 into dx. Minus is there, right? So minus is there, is equal to 0. Now if you want, you can shift this particular thing. And one more thing, be careful here. With x I am having dy, and with y I am having dx. But I need with x dx only. Then only I can get the value of, then only I can eliminate this dx and dy, right? So what I am going to do, I am going to shift this particular thing onto the RHS side. Let us see. This minus will become that side plus. Now I am going to write like this, dy by, this is my negative power is that it will become positive power if you bring down. Now you multiply here and here. Okay, now one equation is formed. What is the step number 3? Step, so whatever the given equation is there, we got the equation, we have to going to solve. Solve in the sense we are going to eliminate this, the dx and dy, we are going to get it in terms of x and y. The basic thing is that integration we are going to do, because we have to remove dy and dx. Put equal to c on the other side, because there it is 0. Okay, integration constant. So integration of y power 1 by 3. So which formula we are going to apply? See, we have studied x power n integration is equal to what? X power n plus 1 by n plus 1. The same formula has to be applied. So that becomes y power 1 by 3 by 1 by 3 plus 1 is 4 by 3 minus x power, it becomes, sorry, x power n plus 1. So here it becomes 4 by 3 by 4 by 3. So x power 4 by 3 by 4 by 3, because it is n plus 1 by n plus 1 equal to what? Integration constant c. So 4 by 3 is common over here, you can shift right this, and x I'll bring it first, y second. So I have to just multiply with minus sign. So what happens? X power 4 by 3 I'll bring first, minus y power 4 by 3. I am just multiplying with minus sign. So when 4 by 3 goes there, it is 4 by 3 only, but when I multiply with minus sign, both sides I should multiply. So this particular thing, constant value, I can take it as k. The final result will be x power 4 by 3 minus y power 4 by 3 equal to what? The k value. This is nothing but the orthogonal trajectory of the given equation. Okay, so OT is basically orthogonal trajectory.